Okay, so empirical formula is a reduced molecular formula. It's pretty much just the lowest ratio of elements in a compound. Okay. We use empirical formulas to discover the formulas of unknown compounds. So we can use that in more information in order to figure out what the formula of the compound is. Okay, so for example, if I have my molecular formula as C6H12O6, I can reduce this ratio, from 6-12-6 to 1-2-1. So my empirical formula for this compound would be CH2O. Next one we have is C2H4O2. Again, this one also can be reduced to 1-2-1. And then sometimes your molecular formula and your empirical formula are the same. So if we look at this one, it's already been reduced. So multiple compounds can have the same empirical formula. All right, so how do we find the empirical formula of a compound? We're going to be using mass percent in order to do this. For some of them we'll just use the mass that we are given in the problem. There's like kind of two types of problems for empirical formulas, but the steps are pretty much the same. First thing you want to do is to convert to moles. So you're going to use the molar mass of that compound, of that element in the compound, to convert from mass to moles. Second step, and this is the key one, this is the one a lot of people tend to skip over. Because we're looking for a ratio, you want to make sure that you divide your number of moles of that element, of each element, by the lowest number of moles, because we need a whole number ratio. Okay, and again, this is the step that tends to be forgotten a lot. It gets skipped over. So make sure you divide by the lowest number. And then the last one is if you're given the molar mass of your molecular formula, so that's the molar mass of your molecular formula. You can find the molecular formula by dividing that mass by the empirical formula and then multiplying that number by the subscripts in your empirical formula. And we're going to do some examples. So I should also put here must be whole number. Sometimes you don't get a whole number when you divide by the lowest number, so you might have to multiply by 2. Like if you end up with like 1.5, well, in a compound you can't have 1.5 of an atom. It doesn't work like that. So you might have to multiply by 2 to get a whole number. But whatever you do to one of them, you have to do to them all, just so you know. All right, so we're going to do the sample problem. This one's a good sample problem because it is a long one. Okay, so we're going to calculate the empirical formula given this percent composition, okay? And then we're going to calculate our molecular formula because it gives us our molar mass of the molecular formula. Okay, so first thing we want to do is we want to convert these to moles. Now, when we're given percent composition, okay, assume that you have 100 grams. If I have 100 grams of this compound and 27.5% of that is carbon, how many grams of carbon do I have? 27.59, okay? It just makes it so that you can change that percent into a gram. So I'm going to get all of my grams of my elements. So I have 27.59 grams of carbon, 1.15 grams of hydrogen, 16.09 grams of nitrogen, and then oxygen, 55.17 grams of oxygen. That's a periodic table. I do not have a periodic table. Okay, next thing I'm going to do is I'm going to convert these to moles. So Just need to use your masses off the periodic table for this because they're just elements. So carbon is 12.011 grams in 1 mole. Hydrogen, 8 grams in 1 mole. Nitrogen is 14.007. And then oxygen, okay, so calculate all of your moles, and you should have 44344, okay. Moles, let's see. Okay, so we've converted all of these into moles. So the next step is going to be divide by the lowest moles. So what's the lowest number of moles? The hydrogen. So I'm going to take all of these and I'm going to divide it by the number of moles of hydrogen. So I'm going to take this, I'm going to divide it by 1.14. So 2.297 divided by 1.14. Okay, so sometimes you get, and you're probably always going to get numbers like this where you have all these decimals. This is 2, okay? So you're just kind of rounding to that whole number. Okay, for this one, it's going to be 1. Hopefully you can obviously see that. This one will end up being 1 too, but if you actually type it into your calculator, you end up with this. Again, just round. The only time you won't round if it's like 0.5. So if this came out to be 1.5, don't round that, because then you'll just have to multiply by 2 at the end. All right, 3.448. 3. Okay, so these numbers here, these are your subscripts. So for the empirical formula for this compound, you're going to have C2, HN, and then O3. So those numbers become your subscripts. So that's your empirical formula. Okay. So for molecular formula, we need to take the molar mass of our molecular formula, which is at 180 grams, and we're going to divide it by the molar mass of this, of our empirical formula. So I'm going to take 2 times 12.011 plus hydrogen is 1.008, 14.007 plus 3 times oxygen. I think I just hit my okay. 87.014. Okay, so that's the molar mass of the empirical formula. All right, so I'm going to take 180 divided by that. And you get this. So again, just like what we did here, this number is 2. So now, this is what you multiply subscripts of your empirical. So to find my molecular formula, I'm going to take the 2 subscript here, so that becomes a 4, so 2 times 2. I'm going to have 2 hydrogens, 2 nitrogens, and 6 oxygens. Okay. Any questions over? It's just a series of steps, essentially. Don't forget to divide by the lowest number of moles. Yeah.
Where did the 180
this was in the problem right here. It gave it to you. Yeah, so they'll always give you, if they asked you to find the molecular formula, they have to give you the molar mass of it. There's no way to like calculate that. So that's one type of empirical formula problem where they give you that percent mass data. The second type of empirical formula problem is where they actually just give you the mass in the compound. So for example, with this next problem, it tells you that you form a compound by heating 0.3546 grams of vanadium and 0.2784 grams of oxygen. Okay, so the first thing you need to do is to calculate your total mass of your compound, because we need to figure out, do we need to do that? Hold on one second. I'm going to actually do that. No. Oh, wait a minute. We don't need to do that. Not until later. We can do that later. Okay. So with this one, it's skipping that first step where you assume that you have 100 grams of compound, because it already gives you the grams. So we have 0.3546 grams of vanadium and 2784 grams of oxygen. So then we can just jump right into converting to moles. So vanadium is 50.942. And then oxygen, 15.999. We have 4. Okay, so now that we have moles, the next step is to divide by the lowest number of moles, right? So that's going to be our vanadium. Okay, so here is that where I was talking about last one. So if you notice, for when I divide for my oxygen, it doesn't end up being a whole number. It ends up being 2.5. Okay, don't round it when it's like that to a whole number. So because our empirical formula needs to have whole numbers, what I have to do is I need to multiply these guys by 2 to get to a whole number and still have the same ratio. So when I multiply these both by 2, I end up with a ratio of 2 to 5. So for my empirical formula, it's going to be V2O5. So 0.5 is probably the most common one. And then if you have a 0.5, it's by 2. Sometimes you'll get 0.25, so then you need to multiply everything by 4. And then even less common is the 0.33, so that's like a third, and then you need to multiply everything by 3. So just be careful of that. Most of the time it doesn't happen very often, but it does occasionally.